Hello everyone. In this video, I am going to discuss about mesh analysis. Yeah. Mesh analysis is the application of Kirchhoff's voltage law (KVL). Mesh analysis is the application of KVL, and it is used to find the mesh currents. It is used to find the mesh currents. It is used to find the mesh current. And procedure to find the mesh currents. There is a four steps. First step, we need to identify the number of meshes in a given circuit. We need to identify the number of meshes in a given circuit. And second, assign all mesh currents in clockwise direction only. This is very important step to write the mesh equations. Step 2 is very important. Assign all mesh currents in clockwise direction only. In clockwise direction only. Next, step 3, apply KVL for individual meshes. We need to apply KVL for individual meshes. And step 4, solve the mesh equations for mesh currents. Then, and notes, remember the number of mesh equations is equal to B minus of n minus 1. This is the formula used to calculate the number of mesh equations. E is equal to b minus of n minus 1, where b is equal to number of branches and n is equal to number of simple nodes. Remember, n is equal to number of simple nodes here, and this is the formula. E is equal to b minus of n minus 1 to calculate the number of mesh equations, and where n is nothing but number of simple nodes. N is nothing but number of simple nodes. Or direct formula is that the number of mesh equations is equal to number of meshes in a given circuit. The number of mesh equations is equal to number of meshes. This is direct, and this is the formula. It is very important. And next, the mesh equation. The mesh equation. The mesh equation is in the form of KVL plus Ohm's law. KVL plus Ohm's law. And this is also important. The mesh equation is in the form of KVL plus Ohm's law. Mesh equation is in the form of KVL plus Ohm's law. This is the purpose of mesh analysis. It is going to calculate mesh currents. It is the application of KVL, and there is a procedure to find the mesh currents. First, we need to identify the number of meshes, then assign all mesh currents in clockwise direction and apply KVL for individual meshes and solve the mesh equations. This is the formula used to calculate the number of mesh equations. And the mesh equation is in the form of KVL plus Ohm's law. Next, I'm considering simple problem. Application of mesh analysis. Yeah, the problem is that find the find current in each resistor and power delivered from the source in the given circuit shown in figure. Okay, and simple solution. What is the first step? Step 1, we need to identify the number of meshes in a given circuit. Solve the problem according to the steps, and it is easy to calculate the currents in each resistor. Step 1. Yeah. How many number of meshes in this circuit? There are three meshes. One, two, three. Three meshes in a given circuit. Number of meshes. Number of meshes is equal to 3. Number of meshes equal to 3. Is this clear? One, two, three. Next, step 2. Step 2. Assign 3 mesh currents. 3 mesh currents. Mesh currents I1, comma I2, comma and I3 are in clockwise direction only. In clockwise direction, clockwise direction only. For this is mesh 1, this is mesh 2, and this is mesh 3. Okay, and the current in the mesh is I1, and this is I1, this is I2, this is I3. Three mesh currents. This is the direction of current in the mesh. Mention the direction also, it is very, very important. These are the three mesh currents. Step 2 completed. Next, step 3. Step 3. We need to apply KVL for these three meshes. First, apply KVL in mesh 1. Apply KVL in mesh 1. This is my mesh 1. First, observe how many branches are connected in mesh 1. Then 1, 2, 3. There are three branches connected in mesh 1, two resistors and one voltage source. Two resistors means in resistor voltage drop is occurring. We know that we are already discussing in the sign convention. Two resistors are connected and one voltage source. We know the voltage drop or rise across this resistor based on the current direction. Then we are starting from this 2 ohm resistor. This 2 ohm is connected between mesh 1 and mesh 2. 2 ohm is connected between mesh 1 and mesh 2. Then there are two currents are flowing. I1 current is flowing like this and I2 current is opposite direction. Therefore, it is a resistor means first we need to write minus sign, that is minus 2. Okay, now then currents. The difference of two currents I1 minus I2. I1 minus I2. Next, coming to this 12 ohm resistor, it is also resistor. First, write minus 12. Then the currents. Identify the currents which are flowing in this 12 ohm resistor. I1 and I3. I1 is clockwise and I3 is anti-clockwise. It is I1 minus I3 is equal to 0. I1 minus I1 minus I3 not equal to 0. Yeah. Then coming to the source, 48 volt voltage source. The current is flowing from negative to positive, means lower potential to higher potential. Voltage is rising. Voltage rise, we are considering positive. For plus 48 is equal to 0. Yeah. Then simplify this equation. Minus 2 I1 plus 2 I2 minus 12 I1 plus 12 I3 plus 48 is equal to 0. Then minus 14 I1 plus 2 I2 plus 12 I3 is equal to minus 48. This is equation number 1. This is equation number 1. Next, apply KVL in mesh 2. Apply KVL in mesh 2. Apply KVL in mesh 2. Yeah. Then how many elements are connected in mesh 2? 1, 2, 3. 3 resistors. All are resistors means all are voltage drops. Okay. I'm starting from minus 6 ohm resistor. This is the resistor, right? As it is minus 6. What's the current flowing in 6 ohm resistor? Only I2. Minus 6 I2. And coming to this 12 ohm, it is resistor. First, we need to write minus 12 and I2 and I3. I2 is clockwise and I3 is opposite. I2 minus I3. And next, coming to this 2 ohm resistor. Resistor means first we need to write minus 2. Then currents I2 minus I1 is equal to 0. And simplify it. Minus 6 I2 minus 12 I2 plus 12 I3 minus 2 I2 plus 2 I1 equal to 0. Then it is 2 I1 minus 18 20 minus 20 I2 and plus 12 I3 is equal to 0. This is equation number 2. Yeah. Next, apply KVL in mesh 3. Apply KVL in mesh 3. Apply KVL in mesh 3. Yeah. Only two resistors are connected in mesh 3. Only two resistors are connected in mesh 3. We are starting from this 12 ohm resistor. Resistor means minus 12. The currents I3 minus I2 coming to this 12 ohm resistor minus 12. It is I3 minus I1 is equal to 0. Then simplify. Minus 12 I3 plus 12 I2 minus 12 I3 plus 12 I1 equal to 0. Then it is 12 I1 plus 12 I2 minus 24 I3 equal to 0. This is equation number 3. Equation number 3. Then step 3 is completed. Next, step 4. What is step 4? Solve these three mesh equations for mesh currents. Therefore, by solving equations 1, comma 2, and 3, we can get I1, I2, I3 values. Yeah. Use the calculus to solve the equations, then we are getting exact values. Equation 1 value minus 14 and 2 plus 2 and plus 12 is equal to minus 48. Then equation 2 plus 12 plus 12 minus 24 is equal to 0. Equation 2, 2I1 minus 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 20 I2 minus 20 I2 and I3 value plus 12 is equal to 0. Next equation 3 plus 12 I1 plus 12 I2 minus 24 is equal to 0. Let's verify. Equation 1 minus 14 I1 and plus 2 I2 plus 12 I3 is equal to minus 48. And equation 2, 2 I1 minus 20 I2 plus 12 I3 is equal to 0. And equation 3, 12 I1 plus 12 I2 minus 24 equal to 0. Right. Then press equal. Then we are getting I1 value. I1 is equal to 14 amperes. I2 is equal to 8 amperes. and I3 is equal to 11 amperes. I3 is equal to 11 amperes. Is this clear? Yeah. Now the question, they are asking to find current in each resistor. Current in each resistor. Suppose first I am finding the current in this 2 ohm resistor. 2 ohm resistor. Yeah. To find current in 2 ohm resistor, current in 2 ohm resistor. It is, I am assuming I 2 ohms it is. That is equal to I 2 ohms is connected between mesh 1 and mesh 2. Okay, na? Mesh 1 current is I1 and mesh 2 current is I2. Okay, na? I1 is 14 amps and I2 is 8 amperes. Therefore, the current flowing through the 2 ohm resistor is the difference of I1 minus I2. Is the difference of I1 minus I2. I1 minus I2. Because since 2 ohm is connected between mesh 1 and mesh 2. Mesh 1 and mesh 2. Therefore, I1 is 14 amps and I2 is 8 amps. Therefore, the current in 2 ohm resistor is 6 ohms, 6 amperes. 6 amperes. Next, the current in this 12 6 ohm resistor. First, we need to find the current in 6 ohm resistor. Current in 6 ohm resistor. Because 6 ohm is connected only mesh 2. Observe clearly, this is important to find the resistance in each element, each branch, current in each branch. 6 ohm is connected, 6 ohm is connected in mesh 2 only. Mesh 2 only. Therefore, therefore, I6 ohms is equal to I2 mesh 2 current, that is equal to 8 amperes. Is this clear? Yeah. Next, find current in 12 ohm resistor. This one. Okay. Suppose, and this is the point. Assuming this is point A and this is point B, and this is, suppose this is point C. Just assuming the current flowing through point A to B, in between A to B. Current, observe, this 12 ohm is connected between mesh 1 and mesh 3. Mesh 1 and mesh 3. The current in 12 ohm resistor, 12 ohm resistor. Yeah. 12 ohm is connected between mesh 1 and mesh 2. 12 ohm is connected between 1 and, sorry, 1 and 3. Therefore I12 ohms is nothing but I1 minus I3. I1 minus I3, that is equal to I1 is 14 and I3 is 11. Therefore, the current is 3 amperes. The current is 3 amperes. Current is 3 amperes. Again, We need to calculate current in this 12 ohm resistor. Current in this 12 ohm resistor. It is connected between mesh 2 and mesh 3. Mesh 2 and mesh 3. Yeah. Current in 12 ohm resistor. It is 12 ohm is connected between 12 ohm is connected between 2 and 3. 2 and 3. Suppose and this is the point A and the current is towards the junction. Okay. And suppose it is also I12 ohms. It is I3 minus I2. I3 minus I2. I3 is nothing but 11 and I2 is nothing but how much I2? 8. Therefore, it is 11 minus 8. It is 3 amperes. 3 amperes. Next, last power delivered from the source. Power delivered from the source. Observe clearly. This 48 voltage source is connected in only mesh 1. 48 voltage source is connected in only mesh 1. Therefore, the current through the 48 voltage source is I1 only. Current flowing through the 48 voltage source is I1 only. Therefore, for power, I am writing P48 volts is power delivered by the source. P48 volts. I am writing P48 volts. That is equal to P is nothing but V into I. V is nothing but 48. I is nothing but 14. Okay. And that is equal to 672 watts. P48 volts is equal to 672 watts. And this is the solution of the circuit. The way we need to calculate the currents by using mesh analysis. By using mesh analysis. Just highlight the answer. This is I12, one more I12. Yes. This is the source value. Is it clear? Yeah. Thank you.